So this is 1.8 and we want to solve other types of inequalities. So we did linear inequalities in the previous section. So and absolute value inequalities, right? And so this is another type of inequality. So we are doing polynomial inequalities here. So it's a quadratic. So once again, when you solve an inequality, you just start assuming just as if you would for a linear equation, separate the variables, but you got to be careful when you're dividing and multiplying, right? Same deal here. You kind of think of this as a quadratic equation when you start, but you got to be careful after that. So when you solve a quadratic equation, the first thing that you do is you make sure that everything comes onto one side, leaving 0 on the other side. So that's the first thing that you do. But in this case, you can see that you have done it already because there's only 0 on this side. And then the thing to do would be to factor the left hand side. So if you take the left hand side, so you have a -3, right? So you can easily find factors of -3 which add up to -2, which will be -3 times 1, right? Okay, so what you do then, we already have two factors now, x minus 3 and then x plus 1. So at this point, actually, you need to be careful now, right? Okay, so you don't have roots here, but then you can kind of think as the two roots. I mean, this is not root because this is not a equality, but you can see that 3 is an important point. I like to call them like important points. So 3 is an important point, and the other important point is the other kind of root, which is what? -1. So at this point, these are actually like boundaries where the sign of this expression changes. So what I would want to do next is actually I want to put a kind of a sign diagram. So we want to take 3 and -1, our so-called roots of this equation, right? Okay, they're not really roots because this is inequality, but they are like, if this was an equality, these would be the roots, 3 and -1. And create a sign diagram. So the sign diagram, the way I create is this. I go to the smallest one and the next one. So I look at the interval before -1. That means all the way up to -1. That will be one part or one barrier. -1 is a barrier. And then 3 is another barrier. And after 3. So before -1, between -1 and 3, and after 3. So there are 3 sections. The next what I'm going to do is I'm going to take test values from each of these sections. So first of all, I go to the smallest one, -1, and I take a test value less than -1. Okay, so what would be a good test value less than -1? Be -2, right? So now I take the -2 and plug it up here in my expression. So -2 minus 3 times -2 plus 1, -2 minus 3, -2 plus 1. So -3, 2 minus 3 would be -5 times -1. That would be positive 5. But the answer you get is positive, right? Which is not what we want because we want our expression to be negative. So in this region, when you plug in a test value, we get a positive answer, which is not valid. This is not good. So you cross out that region. Then so smaller than -1 is not good. Now we look at in between -1 and 3. So that's our next region, -1 and 3. So what would be a good value between -1 and 3, a test value? Well, between -1 and 3, the best test value, the easiest one to plug in would be just 0. So you take 0 and once again you put it up here, 0 minus 3 times 0 plus 1, 0 minus 3 times 0 plus 1. So you get -3, right? 0 minus 3 times 1, and you get -3 as the answer. And you get a negative answer, which is good because you want the expression to be negative, which means that in this region, the expression is negative, and that is the region that we want. So that's the region that we want. So we put a tick there. Now we go to the region after the bigger value, which is what? 3. So Less than -1 is not good. Between -1 and 3 is good. And then we go to what happens after 3. So after 3, we take a test value. So which is which you can take anything 4, 5, 6, 7, 8, 9, but let's take 4. So if we take 4, and if you plug in that, and we go and plug that up here, so you get 4 minus 3 times 4 plus 1. So 4 minus 3 is 1, times 4 plus 1 is 5. So 1 times 5 is 5, and that is positive, which is not good because we want the expression to be negative. So we cross out that region. The only region that works is this region between -1 and 3. So that is our answer. So what we do is our answer is -1 and 3, -1 x and 3, right? And we want to write it in the internal notation. We can write it as -1 and 3, -1, 3, parenthesis, parenthesis, because it's less than, between -1 and 3. And if we want to draw it in a graph, we have -1 here, we have 3 here. Make sure that we have parentheses and not square brackets, right? And it's between -1 and 3. And that's how you solve an quadratic inequality. So you make sure that your left hand side, everything is on the left hand side and only zeros on the right hand side. Factor as usual. Get two kind of roots which are like key points. Then take a number less than the smallest root. So let's take a number less than -1, a test value, right? And then plug it in, test the value. If the sign is correct, then that value region is good. But in this case, the sign is positive, which is not good. So you cross it off. And then after you test the value less than the smallest value, you test a value between the smallest value and the next one. So we took 0 and we plugged it in and we got good. So that's a good region. And then after that, we go to the largest value and then you take a number. So less than this, and then in between them, then greater than that. So we plug in a number such as anything greater than 3. So plug in 4, and again we got a positive number which is not what we want. Crossed it off. So the only valid is between -1 and 3. That's our region. Thank you for watching.